In the previous clip, looking at the equation y double prime minus y equals cosine of t, we follow the integration by parts procedure to get our u1 prime and u2 prime functions, which we then integrate to get our u1 and u2 functions. Now I've shown the integration by parts to get the u1 function. I'm not going to show the integration by parts to get the u2 function, which is very, very similar. And again, that's a first semester or first year calculus technique. We've reviewed it, and we probably aren't going to do any more of those on screen here. In any case, we get our u1 and u2 functions. Remember, our assumption was that yp equals u1 y1 plus u2 y2, so that using that with y1 of course equal to e to the t, y2 equal to the e to the negative t, our assumption from the fundamental set, we get our yp function. So u1 is our function 1/2 e to the negative t times sine of t minus cosine of t, and that's going to be multiplied by y1, and y1 is e to the t. And then it's going to be plus u2 y2, u2 being negative, we'll write this as negative 1/2 e to the t times sine t plus cosine of t, and that's going to be multiplied then by the y2 function, which is e to the negative t, and we end up then with yp equals 1/2 times the quantity sine of t minus cosine of t, noting that the e to the negative t and e to the t multiply out to give us 1, and then it's going to be minus 1/2 e to the t multiplied by sine t plus cosine of t, and I wrote down the e to the t. The e to the t is going to multiply the e to the negative t, and I didn't mean to write that down. I was going to leave those off, so I'm going to correct that real quickly. Okay, now we've got it right. The e to the t, e to the negative t give us 1, and we're just left with this. And very clearly then, yp equals, if we add these, the 1/2 sine t and the minus 1/2 sine t are going to subtract off. We're going to end up with negative cosine of t. Now that's good, except that we already know that the particular solution should have a 1/2 in there. Okay, it should be negative 1/2 cosine of t. So this means that we did something wrong, and it's not difficult to trace down the error. Here I did the integration of e to the negative t cosine of t, and I got this. But the u1 prime was 1/2 e to the negative t cosine t. I didn't include the 1/2 here. I was just going to do this integral. And then I forgot to reintroduce the 1/2. So that the integral of e to the negative t cosine t is this, but we need 1/2 of that integral, which is going to make this 1/4, and it's going to make this 1/4. Now I'm going to introduce those corrections real quickly, and then we'll verify our solution. Okay, I've simply rewritten everything that went before with the 1/4 here and the negative 1/4 here, and everything works out. The algebra is completely straightforward, very similar to what it was before. Now our question is, our final solution then is yp equals negative 1/2 cosine of t. Now the question is, does this work out? Well, if yp is negative 1/2 cosine of t, yp prime equals 1/2 sine of t, so that yp double prime equals 1/2 cosine of t, and we get yp double prime being 1/2 cosine of t minus yp, which is minus negative 1/2 cosine of t equals cosine of t, and obviously when we add these we get cosine of t equals cosine of t, so our solution checks. Now it was actually a lot easier when we solved this equation to use the undetermined coefficients method, knowing that our y function would have to be some combination of sine t and cosine t, some linear combination of sines and cosines. So we just do an arbitrary linear combination and plug it into the equation, set it equal to the cosine of t, and solve for our constants. That led to the solution rather easily. Now this isn't really difficult either, but it's a little more involved. Nevertheless, it works for this function, and more importantly, it'll work for a lot of functions where this method does not work. That is, the method of variation of parameters, this method, will work for a lot of non-homogeneous parts to the equation, for a lot of non-homogeneous equations for which we can't easily find the form of a solution, solve for the parameters using the method of undetermined coefficients.